Hey guys, so today we're going to start getting into chapter 11. Chapter 11 is all about statistics. There's some neat things in here and some things that I don't know why they threw in chapter 11, but let's see what we get into with 11.1. So objectives today, we're going to organize and understand data using dot plots, histograms, and box plots. Okay, so we're going to be doing a lot of different types of graphs today, dealing with different types of data. So here we go, 11.1, analyzing data displays. So let's dive right into our first example. So example 1, Manuel plans to buy a new car at the gas mileage shown. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he researched? Okay, so our car has an MPG of 26, and we have this data on a whole bunch of other cars. So Manuel wants to compare individual values, so a dot plot is a good way to show that information. So we're going to make a dot plot of this data. So we're going to create a dot plot of the data by first drawing a number line that represents the range of the data. Plot each value from the table as a dot above the number line. So for our range, we're going to have to find our smallest value and our biggest value. Okay, so looking at this, I'm seeing 25. Is there anything smaller than 25? No, so we're going to go from 25 to, looks like 45 is my biggest. Okay, so I'm going to do a number line from 25 to 45. And here we go. I'll just get a nice straight line this way because I'm lazy. Okay, 25 to 45. So put 25 here, 45 here, 35 goes in the middle. Oops, I want to make that 40. And then you just try to make it as even as you can. Goodness gracious, that should be a 30. I can't count today, guys. I apologize. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that doesn't look too bad. And you can go in and say, okay, 26, 27, 28, 29, 30, 31, 32, 33, 34, 6, 7, 8, 9, 41, 42, 43, 44. Right. And then we're just going to put dots above these numbers. Some people do this with X's, some books do it with dots. It's called a dot plot, so I'm going to go do dots. So first number is 25, so I'm going to put a dot above 25. And I'm going to cross it off just to keep track. Okay, 45. Okay, 26. 35. Oops. 31. 26. 30. Oh, I don't like where I put that one. 28. And I saw 29. 26, 28. 26, 28. 26. Okay, two 27s. And two more 28s. Okay, so there's my dot plot. So a couple things we can pick out. Looks like most of our data values are clustered more down here. I would almost consider 45 to be an outlier because look how far away it is from the majority of the data. Okay, the dot plot, pretty straightforward to make. So let's look at a question. In the dot plot of Manuel's fuel efficiency data, what might account for the outlier? Okay, so outlier all the way down here. What kind of car maybe would that be? Maybe we can say it's an electric car, okay? Or he looked at common cars and then threw in some other fancy car. Okay, sometimes you just get outliers. Okay, so give me a good reason why you might have it. So it might be one of those new hybrids. It might be some super fancy one that not many people own. So who knows? Okay, moving on. So example 2, we're going to talk about a histogram this time. So a marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34 years old. The team is researching the age range of viewers of a certain TV show to decide whether they're to advertise during the show. Data shows the ages of a random sample of 30 viewers of the show. Based on the findings, should the marketing team launch their campaign during this particular show? So just got a whole bunch of data. It's hard to see organized like that. So what we want to do first is to make a frequency table. Okay, so I'm just going to count up how many are in each of these intervals. So I'm going to do tallies. Okay, 14, he's going to fall right here. So I'm going to do tally there. Okay, 21 falls right here. 22, category. 17, 24, 20, 26, 15, 20, 22, 14, 24, 26, 15, 17, okay, halfway through the data, 21, 32, 30, 16, 31, 25, in this category, 25 again, 19, it's this group, 16, 21, 37, 17, 20, 15, and 16. Of course, you could have gone through and counted them and then did the tallies that way. I prefer this way, it just is quicker to me. Okay, so there's my data. So now we're going to make a histogram. So to make a histogram is very similar to a box, like a bar chart. Okay, so I'm going to do my axes. Okay, and then the difference between a histogram and a bar graph is that the histogram contains intervals. So like bar graphs, you think of like the number of people that have a dog versus a cat versus a hamster. Okay, you can't have category. You have just straight categories. Histogram, you have these intervals. Okay, notice our ages 10 to 14, 15 to 19, 20 to 24. Okay, they're intervals, ranges. Okay, so I'm going to put age down here. Okay, you always label your axes and frequency over here. Okay, so our highest is 10, so I got to go 10 marks on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, you can label those. Okay, and then my age, my first is 0 to 4. Then I had 5 to 9. Then I had 10 to 14. 15 to 19, hopefully I can put these all in. 20 to 24. 25 to 29. I'm out of room. Actually, I'll go smaller here. Sorry about that, guys. Okay, let's try this again. Okay, 0 to 4. 5 to 9. 10 to 14. 15 to 19. 20 to 24. 25 to 29. 30 to 34. 35 to 39. And 40 to 44. From here, we just make bars. Okay, 0 here, 0, 5 to 9. Okay, there's 2 and 10 to 14, so I'm going to make a bar come up to here. Okay, we have 15 to 19. We had 5, 9 of those. Okay. Okay, 9 of those, so let's see, draw it all the way up to 9. Okay, 20 to 24, we had 10. Draw it all the way up to 10. 25 to 29, we had 4. 30 to 34, we had 3. Let's see, then we had 35 to 39, we had 1 of those. And sometimes it's helpful to color them in. You don't have to if you don't want to. Okay, but this is what a histogram looks like. Okay, again, we have these intervals. Okay, so remember, we got to answer the question. So let's go back up and see what the question said. Okay, the question wanted to know, okay, I want to target it at 25 to 34. Would this be a good show for 25 to 34-year-olds? Well, look at your intervals. Which two are the biggest? Oh, 15 to 24. I wanted 25 to 34. Okay, notice these two are much bigger. This was the one they really wanted us to look at right in here. Again, it's not as big, so I probably wouldn't use this show. Okay, this show would not be good for that age group. Okay, so based on the random sample, what age group would be a good match? Okay, I again look for the two biggest bars. Okay, 15 to 24. Okay, 15 to 24 would be much better. Okay, example 3, we're going to do a box plot. Okay, it's also called a box and whisker. If I ever say box and whisker, it's the same thing. Okay, hopefully you remember how to do these. So here we go. Students at a local high school organized a fundraiser for charity. Caitlin, which is the student council president, announces that more than half of the students raised over $50 each. The amounts of money raised by a random sample of 24 students is shown. Do the data support Caitlin's claim? Well, let's check it out. Caitlin's claim is about the distribution of values, so a box plot will reveal the information needed. A box plot shows the distribution of the data using a 5-number summary. Okay, and the 5-number summary includes these 5 values right here. So the minimum is the smallest value. Maximum is the biggest value. The median is the middle value in the set when the numbers are arranged from least to greatest. First quartile is the middle number between the minimum and the median, and the third quartile is the middle number between the median and the maximum. So let's go ahead and do this. First thing we need to do is list the data from least to greatest. Okay, so let's go get our data. I'm going to, put this on here. Okay, Alright, so here's the data again because it's annoying to go back and forth. So let's put this in order from least to greatest. Okay, so we gotta look for the smallest value. Okay, see if you can figure it out. I see a 25. Do you guys see anything smaller? Nope. Okay, so 25. I'm gonna cross it off. Okay, there's another 25. Okay, 26. 27. Okay, let's see, 31. 32. 32. 36. 38. 42. I saw another 42. Okay, 45. Another 45. Another 45. 49. Okay, 50. 50. Oh, I missed a 48 in there, so let's see. Squeeze it in. 54, 54, 5. Oh, I missed another 54. Squeeze that one in. 59 and 68. And then I always like to count to make sure I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. Okay, we got them all. So obviously pretty easy. This is my min. This is my max. Okay, so we gotta find the median now. Okay, so the median is the middle. So you just cross one off on each end until you get to the middle. Okay, so cross them out. Okay, I've got 2 in the middle. So my median is 45. When you have 2 in the middle, you have to find the average of the 2. Okay, these 2 are the exact same number, so that's pretty easy. But maybe it was like a 46 and a 48. You would take 46 plus 48 and divide it by 2. Okay, so you get the middle number. Okay, so median we also sometimes call the quartile too. Okay, and I label that with the Q2. Okay, but that's an important number. Okay, so after we find that, we need to find Q1. Okay, it's the middle between our minimum and our median. Okay, so I'm going to do it again, but this time I'm going to start right here. Okay, so the median, we have a different 45, so I'm going to cross this guy out. So we just cross them out till we get to the middle again. Oh, and again, I've got 2 in the middle, so Q2 is 32. And one more time, we got to get to our Q3, so cross them out again. Oh, I have 2 in the middle here. So I'm going to do 50 plus 54 and divide by 2. Or you can think what's straight in the middle of 50 and 54, I get 52. That is Q3. Okay, once I have all of these numbers, I'm not done, unfortunately. Now I got to make my box plot. So the first thing we do with our box plot, or our box and whisker plot, is we got to start with the number line. Okay, so here's my number line. And you need to have a good scale. Okay, we go from 25 to 6 or 25 to 68. I'm not going to put that many numbers on there personally because I don't like to, that's a lot of numbers. So we need to come up with, so let's see, 68 minus 25 is 43. So I need something to go by 43s. 5s might be a good idea to go by. Okay, so I'm going to start with 25 and I want to get up to 70. So 25, 30, 35, 40, 45, 50, 55, 60, 65. Actually, I'm just going to put 70 right there just to make it a little nicer. Okay, so we first start by putting on our quartiles. Okay, so Q2 is at 32. So, good and red. Okay, Q2 is at 32, which is about right here. So that's Q2. Make a line. Same thing with Q3, I'm sorry, that's Q1. Q2 is 45, so put a line. Q3 is 52, which is about right here. Okay, once you have your lines, you're going to connect them to make a box. Okay, this is why it's called a box. Then we put on our min and our max. Now the min is 25, so with these you just put a dot. And the maximum is 68. So that's about right here. Put a dot. Okay, and you connect them to the box with lines. Okay, they look like whiskers, which is why this is called a box and whisker plot. Okay, so looking at the box and whisker plot, 25% of your data is from the min to Q1. 25% of your data is from Q1 to Q2. Another 25% of your data is from Q2, to Q3. And finally another, I don't know why I did that. And another 25% of your data is from Q3 all the way up to your maximum, okay? So notice each little break makes 25% of the data. So let's answer her question. Does the data support her claim? She claims that more than half of the students raised over $50. Well, let's go to $50. 50 is right here. Okay, I have to have 50% or more of those students above that. Well, I definitely have 25% right here. This is another 25% right here. That would make 50, 25, and 25. Is all 50% of that above $50? Absolutely not. Her claim is not supported. Okay, so that's how a box and whisker plot can be very helpful. So let's try another one. Suppose she wants to make the statement that 25% of these students she sampled raised over a certain amount for the charity. What would be that amount? Well, again, remember, each section is 25% of the data. So she wants to know that 25% raised over a certain amount. I would look at this part of the graph. Okay, this part comes down here at 52. So we could say 25% of the students, spell correctly, raised over $52. Okay, that'd be how you could solve that. All right, another example. We got to pick a data display this time. Okay, Helena's dance team scored 68 points at a competition. The scores for all the teams that competed are shown. Helena wants to know what place her team finished. Should she use a dot plot, a histogram, or a box plot? Well, let's think about the three types of data we talked about. A dot plot has dots for each value in the data. It shows clusters of data and it might show the outliers. A histogram groups values of data set into ranges or intervals. Individual values are not displayed, but trends are observable. And then a box plot shows the center and the spread of a data set. Box plot does not show individual data, but summarizes the data using 5 key pieces of information. So what do you guys think would be best? Well, if I want to know what place I scored, wouldn't it make sense to look at individuals? The only graph that really looked at individuals here was a dot plot. Okay, so if I want to know what place my team scored, I would have to go with a dot plot. Okay, what place did she finish? Well, let's make our dot plot and find out. Okay, so make your number line again. Okay, let's see. Smallest value looks like it is about 66. The largest value looks like it's about 80. Okay, so oh no, I lied, there's a 65. That's smaller than 66. Okay, so let's go from 65 to 90. So 65, 66, 67, 68, 69, 70, 1, 2, 3, 4, 5, 6, 7, 8, 9, 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, so let's start plotting our dots. Okay, so 66 right here. I did not want that in purple. 66, 89, 81, 75, 90, 79, 82, 68, 66, 78, 80, 82, 65, 80, 81, 66, 81, 83. 1, 2, 3. Okay, so what place? We know she scored 68. So here's first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Looks like they scored 13th place. Okay, hopefully that makes sense. Okay, another one. What data display should she use if she wants to know what percent of the team scored higher than her team? Well, if you're talking about percents, best choice is box and whisker plot. Okay, because it shows percents. Okay. And that's all I've got for you today. Okay, here's again a little summary. We did talk a little bit about this briefly, but feel free to pause this video and copy some of this down. Okay, you have examples of all of these, hopefully, if you took good notes. And here's your homework tonight. Okay, you are on page 470. You're going to do problems 12 and then 14 through 23. Okay, if you have any questions, as always, please let me know. Hope you guys enjoy.
So